In our last video, we talked about a synthesis reaction. We did 1, 2, and 3 together. You were to do 4, 5, and 6 on your own. If you will, please email me your responses for the prediction of products for numbers 4, 5, and 6. We're going to move on and we're going to talk about a decomposition reaction. A decomposition reaction is the exact opposite of a synthesis reaction, where you're going to have one reactant breaking down to 2 or more products. Here is your chemical equation for a decomposition reaction. Here we have our one reactant, and I know that there's one reactant because there are no plus signs here. And it's going to decompose into 2 products here. I know that I have 2 products because here's my plus sign. Here is an example of a decomposition reaction, what it will look like in the form of formulas in a chemical equation. Here we have our one reactant. Notice how there are no plus signs here, so I know that this is only one reactant that has 2 elements. It's going to break down and decompose into 2 products. I know I have 2 products here because there is a plus sign. So let us look at our decomposition reactions in our reference tables. This can be found on page 6 in your reference table. This is the second chemical equation that is given to you in your reference table. And notice how many different decomposition reactions that we can have. We can have a 2A decomposition reaction, which is a binary compound. Here, your binary compound, represented here, will break down into 2 products. So you're essentially going to take this binary compound, these 2 elements, and separate them. The great thing about your reference table is that your reference table will tell you the answers to all of your predicting of products, especially if we look at number 2B, a metallic carbonate. Here is the chemical formula for a metallic carbonate, where M can be any metal from the periodic table. Here's your carbonate. We're going to decompose and break down into a metal oxide and carbon dioxide. So it already tells you what one of your products is. The only thing you have to do is predict what this product is. This metal is going to be the exact same metal from your reactants. Since it is a metal and we have oxygen here, we have an ionic compound, so make sure that your charges balance out to equal 0. A 2C is a metallic hydrogen carbonate. Here's the formula for a metallic hydrogen carbonate. M can be any metal in the periodic table, hydrogen, and carbonate. It is going to decompose into a metal oxide. Again, check your charges to make sure they balance out to equal 0. Water and carbon dioxide. Again, your reference table is giving you a majority of the answers. The only thing you have to do is predict this metal oxide. Just make sure that you're checking your charges as you do so. A 2D is a metallic hydroxide. Here's the chemical formula for metallic hydroxide. M being your metal, OH being hydroxide. It's going to decompose into, again, another metal oxide. This metal is the exact same metal from your reactant side. This is an ionic compound, so make sure that you check your charges. You will also produce water. Again, reference table telling you exactly what to write down. 2E is metallic chlorate. Here is your chemical formula for metallic chlorate. Here we have M for metal, and here is your chlorate ion. It is going to decompose and break down into a metal chloride, this metal being the exact same metal as in your reactants. Since we do have a metal and a non-metal together, this is an ionic compound, so make sure that you double check your charges to make sure they equal 0. And then we have oxygen. Now be careful with this oxygen. It is diatomic, so make sure that when you write down this answer that you put O2. Finally, our 2F decomposition reaction is an oxyacid that will decompose to create a non-metal oxide and water. Here is your here is where you'll find your oxyacid. Remember, that's going to be hydrogen in the front and a polyatomic ion at the end of your chemical formula. It is going to break down to produce a non-metal oxide and water. So essentially, your polyatomic ion that you had before is now going to be a part of your non-metal oxide. And here's the H from your acid. It has created water. Alright, so like before, we're going to try to do some. The very first thing that we're going to do when we do our practice problems is we're going to look at the reference table and decide what type of decomposition reaction it is, and then we're going to move forward from there to predict our product. Because remember, the reference table is telling you a majority of your answers that you're going to write down for your products. Okay, so here's number 1. We have magnesium carbonate. So remember, the very first thing that we are going to do is we are going to look at the reference table to decide what type of decomposition reaction this is. Well, I have magnesium and I have carbonate. So I have a metal carbonate. This is a 2B chemical reaction. Now, if I'm looking at my reference table, I notice that my product is going to be a metal oxide and carbon dioxide. So since I know carbon dioxide is already a product, I'm just going to go ahead and write carbon dioxide so I don't have to worry about it. So there's carbon dioxide. And then I'm going to write my other product, which is a metal oxide. The only metal that I have here is magnesium. Okay? So since I have magnesium and oxygen together, I need to make sure, there's magnesium, I need to make sure that our charges balance out to equal 0. Magnesium has a +2, oxygen has a -2. So since these balance out to equal 0, my chemical formula for magnesium oxide will just be MgO2. No 2 at the end. Just MgO. Okay? Let's do another one. Here's our next one. We have PCl5. I'm going to look at my reference table and decide what type of chemical reaction this is. I don't see any metals in here, and I don't see an oxy acid. So my only option here is going to be a binary compound. I do have 2 elements. So this is going to be a 2A. I am literally going to separate these elements. I have phosphorus and chlorine. What I need to remember about chlorine is diatomic. Look for the 777 on the periodic table. There are 7 diatomic molecules starting with number 7, and they create a 7 on the periodic table, and chlorine is included in that. So here we have Cl2. Alright, as I'm looking at this, I do notice that it is not balanced. So I would have to go back and balance this equation, which is really simple to do. Alright, I have 1 phosphorus on this side, 1 phosphorus on the product side. Those are balanced. I have 5 chlorines on my reactant side, 2 chlorines on my product side. This is not balanced. But I can add a couple of coefficients here to help me out. I can put a 2 here, a 2 here, and a 5 here. And now I should have a balanced chemical equation. 2 phosphoruses, 2 phosphoruses, 10 chlorines, 10 chlorines. I'm good to go. Okay? Alright, so let's look at another one. Here we have iron and hydrogen carbonate. Now remember that iron is a transition metal, so I have to figure out its charge by uncrossing my subscripts. So meaning my charge of iron here is 2. Now why is that important? That's important to remember when you are making your products over here, the charge of iron, to make sure that your charges balance out in an ionic compound. Alright, so I'm going to look in my reference table and I'm going to find my metallic hydrogen carbonate. This is a 2C chemical equation. And with a 2C chemical equation, my reference table tells me what 2 of the products are already. It's telling me that water is a product, so I'm going to go ahead and write water, H2O. And it's also telling me that carbon dioxide is a product. So I have H2O plus CO2. And the only thing I am responsible for is figuring out what my metal oxide will be. What my metal carbonate will be. Well, the only metal I have is iron. Okay, I have iron, and I've already decided that its charge is a +2. That's a 2. And then I'm going to find carbonate. Carbonate is CO3, and it has a -2 charge. So these charges do balance out to equal 0. Therefore, my chemical formula for iron 2 carbonate is FeCO3. Okay, so this is my final answer for my prediction of products. Okay, make sure the chemical equation is balanced. If it is not, go ahead and balance it. All right, 2 more. We have mercury and hydroxide. All right, mercury, again, is a transition metal, so I need to check its charge. And then hydroxide is a polyatomic ion. Here we have a metal, hydroxide. If I look at my reference table, I can find that this is a 2D. 2D chemical equation. With a 2D, I'm going to produce a metal oxide and water. So since my reference table is already telling me that water is a product, I'm going to go ahead and write it down so I don't have to worry about it anymore. So water is a product. And then I have a metal oxide. Well, mercury's charge is a +1. How do I know that? Hydroxide has a -1 charge, and I don't see any subscripts here, so that must mean mercury has a +1 charge to balance out that hydroxide. I know that oxygen has a -2 charge. They do not equal 0, so I'm going to need 2 mercuries to balance out that 1 oxygen. So my final chemical formula is going to be Hg2O. And that will be my answer for my prediction of products. All right, last one. We have nickel and chlorate. Remember, nickel is also a not a polyatomic ion. Nickel is a transition metal. I'm going to look at this subscript here to decide what its charge is. So nickel has a +2 charge. Okay, and then I'm going to look at my reference table to decide what type of chemical equation this is. This is, in fact, a 2E, a metal chlorate. My reference table is telling me that my products are going to be a metal chloride and oxygen. So since I already know that oxygen is a product, I'm going to go ahead and write that down so I don't have to worry about it anymore. And then I'm going to create my metal chloride. Well, nickel has a +2 charge. Chlorine has a -1 charge. Therefore, we should have NiCl2. And that is going to be my chemical equation and my products for decomposition reactions. You can go ahead and practice some of these on the worksheet that you have. Email me with any questions that you may come across as you're doing these decomposition reactions.